Are you a Proxmox user tired of managing your VLAN IDs manually? Do you have a complicated bridge network setup, maybe with QinQ, that you're having a hard time replicating across your cluster cleanly? Or maybe you just want to be able to give network resources and VNets permissions so different users can have access to different ones. Whatever your goals, Proxmox's new software-defined networking module has just come out of beta, and it's finally time for me to take a look at it. So come along on this adventure. Bit of a note in this video, the SDN functionality has been in beta for quite some time now, so I've actually been using it for about a year and a half. That said, not all features are out of beta, and I'm only going to cover the ones that are currently out of beta as of Proxmox 8.1. So that includes SDN zones, simple zones, VLAN zones, QinQ, or VLAN in VLAN zones, and the whole permission system related to that. It does not include the IP address management DNS functionality, or EVPN VXLAN. Those will have to come in a different video later. Those are a big topic on their own. I'm sure we can fill a lot of time with just these. Another thing to note, if you have upgraded to Proxmox 8.1 from a previous version and didn't install new, you'll have to do a little bit of installation steps to enable the SDN. So you know the SDN is installed. If you go to Data Center and see SDN here, and you see local net, that's my local networking. In case it's not installed in your system, you can install apt install libpve network perl, and in my case already installed because Proxmox 8.1 installs it. Also, if you've upgraded, you'll have to add a line to your etc network interfaces file for SDN. If you installed 8.1 from scratch, this will already be there. If you upgraded, it won't. So here's my etc network interfaces, and just at the beginning. So I had source etc network interfaces.d /*, so it'll include all files in this folder. We'll save that. So now we should be good to go. So let's do a quick review of what networking was like before SDN. So in my Proxmox system here, we would generally come down to network, and you would add VM bridges, Linux bridges. So we can create more of them, and create a VMBR1. Go ahead and create that. So essentially, these were the bridges we would use to attach to different physical interfaces. So this one's attached to ENS18, wherever that goes on my network. This one's not attached to anything, so it's just for VMs to talk to each other. Coming over to the VMs then, I could click on this guy and I could choose which bridge I'm going to connect him to and what VLAN tags. Maybe he needs VLAN 666. Maybe this guy, maybe he needs VLAN 420. So all of this works very functionally. As long as you make sure your VMBRs are connected to the same networks on every node in the cluster, everything will just work pretty seamlessly. The problem comes from a couple places. First of all, we want to use VLAN tagging. We either have to create a whole bunch of bridges that are not VLAN aware, parented to Linux VLAN interfaces, which takes a lot of time to configure, or we have to just type the VLAN ID directly in the VM config, and that can lead to errors if we don't remember what our VLAN IDs are. Also, we don't have the ability to restrict certain users or groups from accessing different VNets. Everyone can always access all the VMBRs. They can set whatever VLAN ID they want when they configure their VM. As long as they have permission to configure VM networking, they can mess with all these settings. I actually already did a video completely explaining this topic, link up here somewhere. And so if you're interested in the basics of Proxmox networking, go see that video first. So now with SDN, how does this change? So previously, we do all of our network configuration within the node. So if we had multiple nodes in the cluster, we have to go to each one and set up their networking. And this makes some sense because each node could have different types of interfaces, things like that. But for the higher level setups, the VM bridges, those shouldn't change per cluster node. The low level stuff like the IP of the node, the exact wiring, that can change. So we really want to divorce those two concepts, and that's what SDN does. So now SDN, we go to Data Center, and we get down here to SDN. So this first screen just shows us an overview of the status of each node. Anytime we make changes in SDN, we come back to this screen and click Apply. It'll roll them out to all the nodes in the cluster, all at once. It's also possible that some cluster nodes might have different networking configurations, and they will fail to roll out some of our changes. And so if any nodes fail, you'll see that here as well. So coming down from SDN, we have zones, VNets, options, and IPAM. And I'm really only going to cover zones and VNets today. So in the SDN hierarchy, VNets are a lower level than a zone. So a zone is a container that contains multiple VNets. A zone might be a simple bridge that only exists on a single node. It's a simple zone. You might be using VLAN tagging for your VNets, in which case you'd use a VLAN zone. Or maybe you're using 802.1 AD, commonly called QinQ, VLANs in VLANs. So then your zone would be your outer VLAN tag or your service tag, and the VNet would be your inner tag, your VLAN tag. Whatever hierarchy you choose, the zone is where we apply permissions. So we give users permissions to access resources in the zone. Then we create VNets in the zone, and we don't specify individual permissions on the VNets, just the zone as a whole. So as an example over here, I can create a new zone. And so the first three are the ones I'm covering in this video, so simple, VLAN, and QinQ. So a simple zone just exists on each node individually. They don't communicate across the cluster. If you're using a single node, this obviously doesn't matter to you because you don't have a cluster. So we'll create simple zone, all nodes, no restrictions, and let's add that. Very often in SDN, names have character limits because these go directly into the interface names in Linux, which have character limits themselves. So if it gives you a character limit, usually it'll give you a field to add a longer name. That's not the real name, I guess, in Linux. These also have some limits as well, like they can have spaces and special characters, but they can be longer. So now that we added this, we can go back to SDN and hit apply. If we pop up the thing down here, we'll see network reload is happening. So it's showing up on our node. You'll also notice at this point that there's a zone that already exists called LocalNet. LocalNet is a combination of all of the VMBR bridges that already exist. So it creates a permission entity in the permission system for LocalNet. And so if you're already using VMBR bridges and want to migrate them over, you get one permission entity that's a zone that covers all of the local nets. And as you migrate them over, you can restrict permissions on VMBRs as you want. So now that I have this simple zone, I can go into VNets. Let's create one. So I can give it a longer name here. The short name probably has to be 8 characters. Now, not all zone types support tags, so just be aware of that. If you're using a VLAN zone, this will be the VLAN tag. If you're using a QinQ zone, this will be the customer tag. If you're using a simple zone, there are no tags. There we go. So it's a new, so it's a pending change. So we have to go back to SDN and apply that. And so it looks like it's ready. So if I come over to a container here, currently it's set to VMBR 0, but now I can switch that over to testnet 1, get rid of the VLAN tag. And so now I can pick my individual VNets here instead of the VMBRs. So if you go through in the system and you create VNets with the correct hierarchy for all of your VLANs, you can get rid of the practice of creating VMBRs and memorizing those VLAN IDs and have them all easy in a drop-down here when you create a VM. So let's go for a little bit more of a complicated setup. Let's do some VLANs. I'm going to guess most of you are probably going to be using the VLAN zone type the vast majority of the time. So let's set that one up. So go here, zones, so we'll add a VLAN zone, and we'll call this HomeNet. So here we have to type in the name of a Linux bridge that will exist on all of our cluster nodes. It doesn't have to be named VMBR, but it has to be a bridge. And this is going to be the parent interface for all of the VNets within this zone. So in my case, it is VMBR 0. There's no restrictions, let's add that. So now if I go to VNets, I can create 2 VNets. So my LAN is going to be on HomeNet VLAN 6. And then my IPv6 is going to be on HomeNet VLAN 9. Let's apply that. So now I can come over here and I can put this container on LAN. I can put this container on IPv6. So now let's give some permissions to these guys. Maybe I have some developers. I want to give them access to only some development subnets, but not the production subnets. Let's set that up. So I already have a user here called test user. We'll just use him. So let's give him a user permission to HomeNet. So you could give him permission to everything. Could give him permission to local network or any of our zones. So home net, give it to test user, and we'll give him a role of SDN user. So SDN user means he can select networks to use on his VMs. So now let's log in as test user and see what he sees when he tries to configure a VM. So now as test user, when I try to add a networking, I only see these two VNets because those are the only two that I have permissions to. I can access the home net zone, but I can't access the local network zone. So I can only choose V6 or LAN. Now there is a quirk to this. If the VM already has assigned a network that this user doesn't have permissions to, then that user can't change any network settings. The VM will still work, they can still configure other settings, but they can't change that network interface setting that someone with other permissions has configured for them. Logged in as my root user again. If I go back here and I set him to VMBR0, and remember that my user does not have permissions to that zone, they only have permission to home net. So let's go log back into test user. So now logged in as test user, I see it's VMBR0. I can start the container, and that worked fine. But I've got to edit it. It gives me an error here because I don't have permissions to VMBR0 that someone else has configured on this VM. And I also can't change it, so I can see the two that I have permissions for, but I still get an error that my permission check failed, so I can't edit this network interface. I can create new network interfaces and edit those, but just something to be aware of when you're dealing with permissions. So now you're telling me, that's great, but how do I get more granular permissions than the whole bridge and all the VLANs? And it's not that hard. Currently I have two VNets here, both under the home net tag. And let's say I want to move the IPv6 one to a LabNet tag. So I'm going to come here, create a new VLAN zone called LabNet. And I'm going to set it to VMBR0. So I can create more than one zone with a parent interface of the same bridge. And since they're each a separate zone, they each have a different entity in the permission system. So I can delegate permissions to my LabNet and my HomeNet zone separately, even though they both share VMBR0. Normally, you would put different VNets inside of each zone so that the VLAN IDs don't overlap, and then your lab VLANs would be in the lab zone, your home VLANs would be in the home zone. They're two separate zones, but they're sharing the same higher level interface. So let's go ahead and create the LabNet. Then over here, we can move this over to LabNet. And we go here and we click apply. It'll propagate that to all the nodes. And now my LabNet shows up here. So now that I have my LabNet, I can go give permissions to different people to my LabNet. So under here under permissions, probably you'd usually use groups, but I'm going to use a user because I only have one test user. So we'll give our test user permission to LabNet, and we'll give him SDN admin permissions to that one. So I've covered simple zones and VLAN zones, and that leaves us with QinQ. So what even is QinQ? So taking a step back a bit, the traffic we send over Ethernet makes up an Ethernet frame. That's layer 2. An Ethernet frame has a couple of fields. There's a source MAC address, that's where it came from, a destination MAC address, where it's going, an ether type, this is the type of data contained in the frame, and then the data. So for normal IPv4 or IPv6, the ether type would be IPv4, IPv6, the data would be the IP packet. So ether types you see a lot are IPv4, IPv4 ARP, and IPv6. But there's also more ether types, and one of them in particular was defined by 802.1q. That's the VLAN tag. So essentially what an 802.1q VLAN tag does is it sets itself up as the ether type, and then its payload data is the VLAN tag. Yes, it has a 4-bit priority, a 12-bit VLAN ID, and then following that tag, there's another ether type, and that's the packet contained within the VLAN frame. So what if we took this little shim header here, we just kept adding more and more of them, shimming more VLAN tags and nesting them down and down? How would that work? Well, people tried this, and it turns out that routing and switching ASICs really don't like when you do this. They're not designed for handling large numbers of nested VLAN tags. But it would be a legal thing to do, 802.1q. So to make this problem more manageable, they formally defined nested VLAN tags in 802.1 AD, and they actually have a separate tag ID for the outer tag. It's called the service tag. And this service tag was originally designed for ISPs and service providers. So customers could send frames that have a VLAN tag, and the service provider could add another tag in between that's the service provider's customer ID. So the customer could have their 4094 VLANs, the provider could have their 4094 customers, you matrix that out and you get a whole lot of VLAN tags. But the provider's network would deal with the 802.1 AD service tags only, and the customer's network would deal with the 802.1Q VLAN tags only. So it's important to know the two different types of tags when we come over here and create a QinQ network. So I'm going to make a zone QinQ. So it's going to be off VNBR0 again. So service VLAN. So the service VLAN is the ID that we as a service provider use. So when you're creating a QinQ tag, your VNets within this have their own VLAN tag within the service tag family. So each QinQ zone we create has a different service tag, and all of the VNets within it are nested under that service tag. So if I really wanted to, I could create 4094 VNets within this one service tag, then create 4094 more under a different service tag. They'd all be distinct to the network topology. That would be kind of crazy though, but it supports it. So in this case, we're going to use service VLAN 69, and we can choose the protocol we use for the service tag. Usually we would use AD if we're doing service tags, and we go. And so other than the fact that VNets within a service tag are distinct from VNets directly on the bridge, QinQ is pretty much the same as creating a VLAN interface. So now that we've had a good chat about the Proxmox SDN system, what are some features that are currently in tech preview that we can look forward to in future releases? The two biggest ones here are the IPAM, DHCP, and subnetting system, which is currently being worked on, and also the VXLAN EVPN system with FRR. So in this video I covered the simple zone, which doesn't actually go anywhere, doesn't connect to anything. And the intent long term is that Proxmox can provide a router functionality on a simple zone. So if you create a simple zone, you can create a layer 3 subnet on that zone. Proxmox can act as the gateway, and it can route packets to the rest of the network on layer 3. It also supports source NAT, so you could masquerade your hosts behind a single Proxmox IP. That's all in the SDN system now in tech preview. The other thing are the two zones I didn't cover, unicast VXLAN and BGP EVPN VXLAN, including layer 3 BGP. So VXLAN is a tunneling protocol that encapsulates layer 2 frames into UDP packets. So if our Proxmox nodes are spread out, they're not connected in the same layer 2 broadcast domain, but instead in a layer 3 routed network, we can send routed packets over UDP through our routers and encapsulate our VM traffic. So if a VM moves around the cluster to different nodes, it has its MAC address, and it'll think it's still on the same layer 2 domain, even though they really aren't switching, we're routing between those. Now VXLAN is very widely used in large networks today because it solves a lot of scaling problems that happen when you try to scale out a layer 2 network to a large size. Expanding on VXLAN, the other option we have is BGP EVPN VXLAN. It's a lot of acronyms. Basically what that does is in VXLAN, we treat each Proxmox node as a switch. So it has a MAC address forwarding table. When it receives a frame from an unknown source, it sends it out unicast to all of the other switches because it doesn't know who might have that MAC address. And that can cause a lot of flooding over UDP if we send out broadcast packets or unknown unicast packets. So to solve the scalability problem with that, with all this flooding, we introduced BGP. So BGP is a very well-known and established routing protocol that can support multiple protocols. It's normally used for IPv4 and IPv6, but you can also use it to route MAC addresses, as weird as that seems. So with BGP EVPN VXLAN, when a node's MAC address is discovered, it sends that MAC address out over BGP. So all of the VXLAN endpoints know where to get to a different MAC address from BGP. They don't have to flood it out over unicast and learn like a switch would. So that's BGP EVPN VXLAN. It's another complicated topic. It's also in Tech Preview. It's something I've experimented with, but I'm not going to make a video on it just yet, but stay tuned for that. So if you like my videos and you want to support me, I have a link down below to my Ko-fi. Any tip is appreciated. I don't have any sponsors on this video, so it's just funded by you guys. If you want to chat with me on Discord, I have a link to the Discord server down below. I talk a lot about Proxmox, networking, other tips like that. And as always, I'll see you guys on the next adventure.